So for homework, you had two problems, both using synthetic division. The first one, you were supposed to use the, one second, I'm getting a weird, I was recording there too. I didn't know I could do that. Okay, evaluate the function x to the third minus 5x squared minus 7x plus 4 at x equals 2. Okay, so again, obviously, right, you can just punch this in, 2 to the third minus 5 times 2 squared, so on and so forth. Okay, but right now we're just using that as a check to make sure that we did the synthetic division right. All right, so we're going to set it up. Remember, because it's x equals, we're just going to take whatever value that they give us here. So on the outside, we're going to have a 2. We write down the coefficients up here. Okay, don't forget, in front of something like this, we have an invisible 1. So that 1 is there. Then we have -5, -7, and 4. Okay, and again, we're just worried about our remainder. Okay, whatever happens in that last spot, that last numerical spot, and we could really care less about what's going on in here. So synthetic division, we bring down the 1. 2 times 1 is 2. -5 plus 2 is -3. 2 times -3 is -6. Be careful here. We are adding two negative numbers, so we're going to get an even larger -13. 2 times -13 is -26. 4 plus -26 is -22. All right, so your final answer there should have been -22. Another way you can write it is, f of 2 equals -22. Right, so there is your answer for the first problem. Any questions
Mr.
about that?
Murray,
Yeah.
if we left it as -22 on the homework, is it fine?
No, yeah. As long as you just put, as long as I see that -22, you're good.
Okay.
Okay. I'm just letting you know that, you can also see that as an answer, or you can also, if you see that, don't get confused. All right. So the second one, and actually we're going to be building on this now, okay, is we're going to use the factor theorem to see if x plus 2 is a factor of our function 2x to the third plus x squared minus 5x plus 2. So remember, okay, our factor theorem says when we do this, okay, our remainder should be 0. Right? If our remainder is 0, then it's a true factor. And what we're going to do is we're going to continue from that. All right. So we're going to set it up. So be careful here, right? So notice here I have x plus 2. Well, if I set x plus 2 equal to 0, x would equal -2. Right? So that's, again, when we have it set up as a linear factor, we have to take the opposite sign. Okay? And again, that opposite sign builds in the whole subtraction part. So we can skip subtracting and we can add down like we do. All right, so we're not missing any variables up here. So we're just going to write the coefficients. 2, 1, -5, 2. Okay. We follow our procedure. We bring down the 2. -2 times 2 is -4. We add down. We get -3. -2 times -3 is +6. -5 times 6 is +1. -2 times 1 is -2. And we get 0. All right, so it is, in fact, a factor. Before I move on, any questions about that? Okay, so what I'm going to do, like I said, is I'm going to continue today straight from here. All right, so since x plus 2 is a factor, remember we can write it using our division algorithm as my original function is equal to the factor part, okay, what we divided by, x plus 2, the divisor, times my quotient, right? So here we don't have the variables. So remember, because we're dividing, we're knocking everything down a degree. So this was originally x to the third. So the variable that gets tied to this first coefficient, 2, is going to be x squared. Okay, so we drop that x to the third to an x squared because we factored out an x in the front here. Then we just follow suit. So we're going to have negative 3x plus 1. Right? So what we're going to be doing today is we're going to check for other factors. Okay, I can continue and try to get this into only linear terms. All right. So we can say, they might give you a second one, right? Is x minus 3 a factor? Now, one thing you can do is you can go back up to this, right, and do the same thing with a 3. But since x plus 2 is already a factor, if x minus 3 was a factor, it would be contained in this, but it would also be contained in what we have left over. So I can set up a new, well, that'll be a positive 3, synthetic division problem, but I don't have to use all 4 coefficients anymore. I can just focus on what was left over. So I'm just going to take what I had in this solution and just bring those numbers down. And it's a little easier because you're dealing with less terms. And it's a little quicker, right? So I'll show you going back with this, but I'm going to show you both ways here. All right, so we have the 2 that gets brought down. 2 times 3 is 6. Did I do something wrong? I may have did something wrong. Well, let's continue anyway. Here we get a positive 3. 3 times 3 is 9, so 10. So that's not a factor, okay? I must have wrote something down wrong. My mistake. Okay, so let's take a look at an example where that does happen. All right, everybody good here? I can move on. Okay, so let's take a look at when it actually does happen, because apparently I messed up. Okay, let's do this one. All right, so here we're going to do it twice. Okay, so we have x minus 2 and x plus 3. We want to find out, are they factors of this? Okay, and then we're going to take it a step forward further and find the remaining linear factors. Right, as long as these two are factors. Now, if they are factors, it doesn't matter which one you start with. All right, so just because it's in order, I'm going to start with the x minus 2. So we have a 2 on the outside. All right, here we have 5 terms, so just be careful, make sure you get them all. So we have a 2, a 7, a -4, -27, and -18. All right, so going through the synthetic division, 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. 22 plus -4 is -18. 2 times -18. No, positive 18. What am I doing? Positive 18 times 2 is 36. Adding down there, we get 9. 2 times 9 is 18. And we get 0. Okay, so it is a factor. So what I'm going to do is I'm just going to put that at the top, x minus 2. All right. So now I want to check, is x plus 3 a factor? Okay, so again, I don't have to do this whole thing. I know if I take out x minus 2, I have this remaining, right? So I would have 2x cubed plus 11x squared plus 18x plus 9. So now I'm going to use these. I'm just going to copy them down here. And now I'm going to do synthetic division with my x plus 3. So I'm going to plug in -3 on the outside. Same process. Bring down the 2, -6, 5, -15, 3, -9, which gets us a remainder of 0. Okay, so coming back to this, I'll put it down here now that we have room. We can write that x plus 3 times x minus 2. And then what do we have left over here? We have a trinomial, 2x squared plus 5x plus 3. All right, and that's equivalent to our original equation, 2x to the fourth. Right, so if we did distribution, we FOILed, we would end up with this. So now we're looking to find the remaining factors. All right, so these are already linear factors, so I'm just focused on this. Now, we haven't really gone over factoring in depth. I know it might have been a while since you've seen it in Algebra 2. Okay, so normally we would try to look for two numbers that multiply to this number and add to this number. But I have a 2 in the front there. All right, so I'm going to have to break this up. All right, so if I broke this up linearly, right, my first term, one of them would have to have a 2x, and one of them would have to have a 3. Now, these are both positive. So in here, they both have to be positive. So now I have to figure out, where do I put my factors of 3, right? What are my factors of 3? There's only 1 and 3. So does the 1 go here and the 3 go here? Or do I flip them and the 3 goes here and the 1 goes here? Okay, so that's kind of a process of elimination. Right, so we can always check by doing the outer and the inner part of our FOIL. So if I do the outer, I get 2x. If I do the inner, I get 3x. When I add 2x and 3x, that gets me the 5x. All right, so we can say our original function, broken up to its linear factors, is those four linear factors, x plus 3, x minus 2, 2x plus 3, and x plus 1. And if you were asked to go a step further to find the zeros, right, you would just set each one of these equal to 0. Okay, so we would have 4 answers, right? And that kind of goes with what we said when we were talking about our polynomials, right? This is a polynomial of degree 4, right? So that tells us we have 4 possible zeros. Well, look at that. We have x equals -3, x equals +2. This would get us a fraction, but that's okay. -3/2, and x equals -1. All right. Any questions about that? All right. So with the remaining time, I want to go back to this. There's a few ways that we can factor this. One of them is called factor by grouping. Did you guys go over that last year? I'll take your silence
Go
as
over what?
factor by grouping.
Yeah, we did, but
Okay.
I don't think I remember it.
All right. So this I like to call the AC method. All right. So let's do a little side lesson here. So let's just say we had, what we had up here, 2x squared. Okay, so here we have I don't need the parentheses. Here we have a trinomial that's in quadratic form. All right, that would be ax squared plus bx plus c. Now, like I said before, if this was just a 1, right, then you just kind of do your regular factoring. What two numbers multiply to c and add to b. But when we have a coefficient in front of the x squared, that kind of throws, a wrench into our gears. So this is a method that I use. It takes a little time and a little getting used to, but it's foolproof. So the first thing you're going to do is multiply a times c. Okay, so 2 times 3 is 6. All right, so now I'm going to use that number with that 5. So I'm looking for two numbers that the first condition is they multiply to our AC, which is 6, and add up to our B term, which in this case is 5. Well, I mean, you kind of have it right here, right? So you have 2 times 3. So what we do is we break up the B term to 2 plus 3. All right, so I would change 2x squared plus 5x plus 3. I would break up this middle part, okay, and it would be, now it doesn't matter how you write it. It would be 2x squared. So I could have plus 2x plus 3x plus 6. Okay, so again, these two middle terms, right, I can have them switched and I can have 3x plus 2, but that's fine. So here's where the factor by grouping comes in. I look at my two terms. What can I factor out of here? All right, well, they both share a 2 and an x. So I pull out a 2x. What do I have left over? I have x plus 1. All right, there's a plus sign here, so that gets brought down. What can I factor out? Excuse me. Oh, wait, you guys, that's a 3. Yeah, okay. So what can I pull out of these? I can pull out a 3, and I'm left with x plus 1. So then I factor out these x plus 1s, and what, I'm sorry, what do I have left over? I have left over 2x plus 3. All right, and that's what we ended up with. All right, so that's just another way we can do it. Sorry if I confused you there. I messed up a little bit with some of the numbers by bringing that 6 down. But it's just another way, instead of doing some guess and check, to figure out how to factor. All right. So any questions?